Hi all, this is a quick overview of the Scala programming languages. So you can download Scala from scalalang.org/downloads. You can treat it as a Maven library, a simple jar. At first when you download Scala, it's best to try the REPL, which is the read, evaluate, print loop, and you can try some operations there like 2 plus 2 and stuff like this. It will return you the result to the screen. You can also ask for the type of stuff. So if you click colon type and you put in parentheses true and 2.0, you will get that this type is a tuple of Boolean and double. And you can also save sessions into a file with colon save. A colon in the REPL is the command for doing meta commands on the REPL of Scala. So colon H question mark would search the recent history. So the basic command for print is just println as opposed to Java, which is system.out.println. Here it's less of a explicit. So we'll skip most of this because we want to go through it quickly. You can do a string.length and get its length. You can do a substring. So you have many additional commands on top of the Java methods. So you have the Java methods, but you could also run take 5, which will take the first 5 characters of a string. You can define simply an array by val a equal array 11, 9, 6. Val is a value, which means it's immutable. It's great. All your code should be with vals, and limit the vars to really the places where you have to, like internal places where you need performance on something like this. You can define a function in a simple line, so you simply write def, the name of the function, and then your variables, and then your output, the output of the function, the output type of the function, and the body of the function. Okay, you could also define functions as values. So function is a first-class citizen in Scala, so it's a value of square, and it's from int to int. The input parameter is int, the output parameter is int, and you simply have from x, and this is the body of the function, x multiplied by x. We'll skip through most of this. Let's get to the more interesting stuff. You have tuples in Scala, so here we have a tuple of 2, a tuple of 3. And the difference between tuples and list is that list is for a single type, but here you see that we have multiple different types in our tuples. Let's move on to some more interesting stuff. You can also define a value of a tuple equals a function, so it will take the function and assign the output into this tuple. So this can be helpful when you have like multiple return types, or you don't have a case class for something, so you simply assign it into multiple variables. Here you defined a simple class dog. You have here the input parameters to the constructor, so when you do new dog you can pass this string. So the string is here and you don't need to explicitly define a constructor. An object is a singleton instance, so you can simply access dog with big D and then access all the methods of it. Of course, you should be careful with using singletons and statics, because it limits your ability to test the code, and it limits your ability to use dependency injection. Here we have a trait. A trait in Scala is like an interface. So we have a trait with a few methods, and you can also assign default value to the trait, and then you have a class which inherits from the trait. So we have a Saint Bernard which inherits from a dog. You could also have a few traits and then you use them in a mixin. A mixin is like you have the class extends the first trend and then it mixins multiple additional traits. Pattern matching, a very strong concept in Scala. This is one of the reasons I love this language. There are other reasons why I hate this language, but this is one of the reasons I do like it. Pattern matching is very strong. You define here a function. The main thing is here. Look how clear this section of code is. You do a case, you pattern match the person, and you say if this person has a name George and any number, then print hi George and the number. So you can pattern match objects based on patterns, and if we needed to write this with an if else or some other construct, it would look much uglier. This is very strong. Okay, let's continue to some more interesting stuff. Of course, you can have some more functional constructs. So we have here a list and we do map on the list and we call the function adds 10, and the function add 10 simply adds a 10. Look how concise this is, very concise. For comprehension. In for comprehension, you use for and yield. So here we take each item in S. For comprehension is a shortcut for flat map and map. So you take every action, every item in S, and you apply a function on the result with the yield. Implicits. Implicits, use it whenever you can't do anything else. I wouldn't recommend you to use implicits at all. Use it when you have to. But it's also a strong construct, but it can make your code very complex, especially to the readers of the code. They won't have any idea where this implicit came from. It can be, if there is one or two or three implicits, it's okay, but once they aggregate, it's like an army of implicits that you need to confront. So you've defined an implicit int here, and then you can use these implicits as standard variables. So we define the init, so we simply use it. Okay, everything is okay and as usual. But if you have a function and you define to it its argument, in this case to whom, a string, and you also defined another argument which is an implicit of int, then the compiler will search for an implicit and it will find the closest one and place it here. So here the how many will catch that other argument of 100 and will print it. You can of course pass variables as usual to the implicits, but if you don't pass, so you have two ways to call this function, one with the explicit argument and one without. And if you call it without, then the compiler at compile time will be able to know that you missed an argument and it will complement it. There are rules for implicits, you can read about it, better to know them. When you do import, this is just about syntax. When you're doing import, you can do a rename to a variable, so you could give them your own names. This can be helpful in cases of collisions. Here is an example of reading a file. You can simply do source from file. Look how concise this is. Source from file, your text file, and get lines, and then for each line you just print the line. And this was our brief Scala overview. I hope you enjoyed it, and I will see you next time. I will attach the resources I used to this lecture below in the description. If you liked it, please share. Thank you for watching.